Okay, so today we are going to talk something called public key algorithms, where we will be using two different keys. And the keys also have names now, right? So in this case, generally in the previous model, with a single key, you can say it's a secret key, right? That will be easier, then easy to remember as well. So that's a secret key. Same secret key has to be shared between the sender and the receiver. But in this one, we have two keys. One is we call private key. The other one is called the public key, right? So this method is also called public key algorithms, but one of the keys are also with that name. So don't get confused here. So public key is one of the keys of the two different keys in the public key algorithms or public key cryptography, right? So name here is public key. Now you might ask, what are these two keys? So let's talk about a little bit on that theory side. That's why it's very important to understand that. So then easy for you all to get this concept going on. So still if you all have any doubts, please do ask questions while I'm going through, right? Even though this is a online lecture. Now, I will say, okay, I will use notations, so then easy for us to remember things, right? So okay, I'll use a different color here. I will call here like this K, right? Then it's private. I put K private. So if it is some other person, I will put here in top A, B, or so then superscript and the subscript will be used. So similarly, this key I will call K pub, right? But then if some sender A or B, or we want to denote that person, so we can put here A or B, right? So that's why I will use the public key and the private key. First of all, this is an important thing. Here you have to believe on one thing, that is the mathematics part, right? Which I'm not going to prove you, or you all need not to know how the proof will be done, right? This public key, private key is a pair. Public key and the private key is a pair. That means they have some relationship between these two. So it's like this, right? So if this is the public key, if this the next one is the private key, so they are somehow connected, right? That's this is the fundamental rule, right? So these are actually mathematically some numbers, right? These are binary numbers. As you know, keys are binary numbers. So these two numbers, which we call prime numbers, right? So you don't need those technical details, but these are big prime numbers, and there is a way to generate these prime numbers to have a relationship. The relationship is if one of the keys, right, is used for encryption. So this these are the process. Encryption, and it's a decryption. So if we use let's say public key, I just put here pub, right? So the public key for the encryption. So this is what I'm saying. So then you have to use the corresponding private key for decryption. So I'm here put a corresponding, right? So of the pair, corresponding means corresponding of the pair. So then these two keys are generated at the same time. Same time using a tool. Now, yeah, so I will show you what the tool is as well, and then maybe you all can try those, right, yourself, and you can create. This is not very difficult, right? So anyone can do, but just a tool. So when you say generate a key pair, right? So each person, like given a person, so this is, I'll take me, Ajanta. So when Ajanta generates keys, right? So Ajanta will be getting, so I'll use a different color. K private, let's say Ajanta A, right? And then K public Ajanta. So this is my pair. This is Ajanta's pair, right? So each person has to generate a key pair, right? So everyone will have to have a key pair, and they are related. The pair I said they are related mathematically. Okay. How? Don't try to ask that question, because that's mathematicians have proven that. Right? Let's take that as a fact, right? So they are mathematically related two keys, right? And they will be generated at the same time. Okay. So then those keys are being used for encryption and decryption. So if you use here one key for encryption, the corresponding other key has to be used for decryption. So then someone can argue with me, sir, is it possible to use a private key here to encryption? I can say yes. So then the corresponding public key has to be used for decryption. So it's like a key pair, right? When you lock with one key, you need the other key to unlock, right? That's the thing, right? You can't use the same key, right? So if you and me just take each of you all as a one person, right? So now you have to think myself and you. So I have a key because we have a key pair. So out of that, I can give you one key. And then when I lock with my key, you can open with the corresponding other key which I have generated. Similarly, if you lock with that key, I can unlock from the key that I have. So remember, lock and unlock will happen with the relationship. So the whole scenario here happens with that relationship. Relationship here in the sense like they will be generated at the same time. They are connected. They are not rather connected, rather say we say they are maybe have some relationship between them, right? So they are part of the pair, right? So these are the basic fundamentals you have to remember when we are doing this, right? So now I'll go to with that description to the slides. So there are two keys. One is called public, the other one is called private. So remember, write it down. This is a pair, right? And need to be generated at the same time. So that is also you can say. Need to be generated at the same time. Then only the pair can be created. Okay. The private key is kept secret. Okay. Now the word private says it's secret. Never be divulged. And it is password protected. Let's be called passphrase is there. That means now, again, I'll take this sender here. Right. So sender will be creating a pair, right? So he will be having, let's say sender is, let's call A, receiver, let's call B, right? So he has a pair. So this pair is K private A, comma, K public A, right? So my A is A's keys. Right here, private or public. So similarly, B is create a pair that is K private B, comma K public B. And that's his pair. So this is the two pairs each person is supposed to have. So everyone has to create their pairs and keep it. But then with the names, we can say this is private means that creator should keep it. Creator should keep this key. Okay. Public means the public key is not secret. Okay. That's very important and can be freely distributed, shared with anyone. So you can say, this is my private key. So everyone, right? So you can give to your You can put a paper advertisement if you want, right? But I think the keys are not really good to do the paper advertisement. These are binary numbers. So then that's not practical. But of course, you can send it as an email. There's no problem, right? So no one is like going to get that is going to be having some impact, right? We'll see that. So as the name says public, just make it public, right? Just put it on your web page, right? Or whenever you write your emails, right? So you have the to, from, body, and then at the footer, you can include your private key, right? This is not private key, I made a mistake, your public key. So sometimes you might have seen some people used to do this, right? At the bottom, there is something looks like it's garbage, like for you all, because it's like some letters and numbers, whatever. That's the key that if you want to use that as a public key, which is someone is giving you. So every person now in this scenario, every person should have a key, okay? And should have a key pair, and one of the key, he or she has to keep it secretly with him. That is we call private key. The other one, you can exchange or you can give it to others, share with others. That's your public key. So now A's public key is this. This is A's public key that A can share with others. So this is a B's public key, which can be shared with others, right? But these private keys should be kept with them, right? So when I put maybe green color, whatever. So the green color ones should be kept with you, right? Should not be shared with others. Right? It has to be private. So this method is called asymmetric key because you can see the two different keys, private key and public key, are being used, right? Because of that, we don't call the same key. Two keys are mathematically related. I told you now, right? They are related, and it's infeasible to derive the private key from the public key. So someone can ask, so if like one key is known, like let's say this yellow key is being known, is there a possibility that we can generate the private key? That's what it says in infeasible, right? I will not say impossible, right? Because nothing can be guaranteed, right? If someone still is not, right? As of today, it's impossible, right? But there will be a day, like if someone was able to do with some mathematics or some technique, right? So then remember, whenever you got to know, right? Mr. So-and-so has created an algorithm to generate or to predict the private key by looking at a public key. Straight away, please stop all your internet transactions, right? No VPNs, nothing, because all will stop at that immediate step, because all are relying on this assumption that you can't really break, right? So whenever you heard that, so don't try to log into internet banking. Straight away go to the bank branch and do the transaction, right? And don't do e-commerce stuff, like, because that is not going to work, right? So that level, that big impact the whole world will be seeing if that happens. But however, that's what, as of today, it's not been happened, right? But I'm not saying that it will not happen at all, because anything is possible. That's where, like I said, I think in previous lectures, I told you, whenever you guarantee, you can guarantee about 99.999, we call 5 nines, right? So then it will be quite safe. At least a small percentage is there. If that happens, we can say there is a vulnerability or whatever. So that's what the vulnerability is all about, right? If someone knows how to break in the sense like predict the private key by looking at the public key, so then like all these things will be disappeared, right? By the way, this method is the last bullet, very much slower. 100 to 1,000 times slower than the secret key, that's a single key method. So yeah, this is very expensive thing, right? This is like this mathematical equations are very heavy. Because of that, we try to compromise the key length, right? As well, like that day also I said, you can increase the key length as whatever you like, but then if it takes about like half an hour to generate the key pair and then use the keys to encrypt, right? So then that's going to be a big time period, and you can't do a transaction because then timeout will be happening, right? So that's where like, so we will try our best to make the required security rather than giving the maximum possible security, because the time it takes is much, much more compared to the single key. But single key we can't use in internet. That is what we have to go for this, right? So now if I just try to clear what I have written here. So this is what I want to highlight. So this is the sender, by the way. This is the receiver. We have the main, whatever the plain text that you want to encrypt, right? You use a key, right? One key you can see here, right? So then one key, and then you can use the other key to decrypt. That's what I was telling, right? Or you can use a private key here, and then you can use a public key to encrypt, right? Sorry, decrypt. So one to encrypt, private, this is public, right? So both are possible, but remember this is has to be the pair, right? You have to use both ends. Now let's see this scenario. I will open a wide screen, and this is where like actually I need your support or your interaction. Let's try to have a scenario and then try to understand this. So this is actually what happens. So now I will say this is A, this is B. This is actually you at home. You are trying to do internet banking with your bank. So B is your bank, A is you, right? So now these are two entities, right? So two users kind of, right? So let's say this is the transaction we are trying to do, right? You are trying to do a transaction and you are trying to pay one of your utility bills now, right? Via internet banking. So this is what you are trying to do. Now let's try to do this exercise with the theory as well now, right? So I said there has to be two keys with each party. Okay, then I will say K public of A, comma, K private of A. Right? So I'll put a bracket here just to make sure that's a pair, right? And there's a comma here as well. Then the K public B, comma, K private B, that's a key pair here. Okay. Okay. Just not a mistake because I thought we'd use a different color. K public B, K private B, right? Now you can say this is one pair, right? This is another pair. Okay, right? So now, let's say now A is going to send some data. So now here my arrow is very important, right? Have a look on this arrow. So this arrow says that you will be sending something, right, to this side. So this is the direction, right? So A is trying to send an instruction. So in this practical scenario, you are trying to tell your bank, please deduct 2,500 rupees, right, for this utility payment, right, whatever telephone bill or whatever, right? This is what you are going to tell to the bank, and bank is going to accept and do that, right? Because you are at home, the bank, you are not at the bank, right? Right. So this, then we have data. This is our data. Data can be anything, right? So the data here is some transaction. And then we can't just send it like that. So we have to give it to the encryption algorithm. I put here encryption E, right? And then we get, once we do that, we get ciphertext, right? The ciphertext is what will be sent over the network, right? And then I'll draw the the second scenario, the receiving side. So then the B bank here, he will be getting some ciphertext, and the bank will be putting to the decrypt mode, right? And then, of course, the bank should get the data, right? That is what the bank should get, the instruction or whatever, right? 2,500 to be paid, right? With the account details, everything will be coming. But the ciphertext is what going over the internet, right? Now, my questions are, there are 4 keys. Which color we can use? What key we should use here? And then what key we should use here? So I want you all to identify with me the key that we can use. So encryption and decryption, you have to have an understanding, right? So there is a key pair with A, public key, and a private key. K A pub, K A private. Then B also has a key pair, KB pub, KB private, right? So there are 4 keys. But I told you now, so that's why, like, again, I'm reiterating. If you use one of the green color key, you have to use the other green color key to you do the opposite of that operation. If you use the purple color, one of the keys, you have to use the other purple color, right? So don't, this is like 2 couples, right? So don't try to mix with different spouses, right? So when you encrypt with KA pub, don't try to use KB private or whatever. You can see that's a 2 different keys. No, these are 2 different pairs as well, right? So don't mix the pairs. So within the pair, it has to be. Okay. So this is what we are going to first identify the theory. So then when I do this as a practical as well with you all, so then you all will understand, okay, this is what it really happens. So I don't mind if you write it down, this piece of paper, this particular transaction, the 2 key pairs, KA pub and KA private, and then the B side, KB pub and KB private. And then this is the data we want to get. And then we can see like data, what is the key we should use to encrypt first. We'll try to discuss that. And then we have to discuss how to decrypt that as well. And that has to work well. Now, I will take, there are 4 keys actually now, right? 1, 2, 3, 4 to do here, right? So there are 4 possible keys. Keys we can use here. But which one is correct, right? So which one we should be using? That is what our question now, okay? Right, I think I have not used the yellow color, but use that. I'll put a dot on the top and try to use, right? So if I use this key, and I'll put a dot here, is private key to encrypt. So my first question is, because we have to first talk about encryption, then only we have to look at the decryption. Okay, now I'm trying to put here KA private, right? So then what is the key we should be using here? If it is that dot, we have to use the other key, right? That is KA pub. But public key, when we use this way, what will happen? Because then anyone knows, like, let's say there are bad guys here. So we have to have a bad guy here. So this is a bad guy, right? Bad. Oops. They'll change. The white screen went. Start again, unfortunately. And so then now I think you all know. I mean, I can go with, I will redo that. Sorry about that. So we have KA, okay, I made that there's KA pub, KA private, yeah, KB pub, KB private, etc. pair. So we were trying to use this particular key, right? data and send to the encryption algorithm, right? And the key. To get the ciphertext, and then with the ciphertext, we get to the decryption, we get the key, and we get the data. Okay, so if I use KA private, which I can use, A can use that because it's A side, right? So then other one can use KA pub, that is also possible because public is a public key. But then there's a bad guy, right? So bad guy also can use that decryption because he also knows that KA pub, right? So then if a bad guy knows the KA pub, so that means there is no security here. So this is encryption, decryption works, right? But we can't really do encryption here because you can create ciphertext with the A private key, but then anyone can open since everyone knows A is public key. So that's because of that, I would say this key we cannot use for encryption. So I will just cut down that, right? But then someone can say, can we do the other way around, right? Okay, now I will cut down this as well. So I will write it again. I use the same color. KA pub you can use, right? So in that case, can we cut down that piece also? So then what the key we have to use here, right? If you are using KA pub, so someone has to use, the description has to use KA private. But only thing is, private keys are only for that particular person because no one else will know about that key. So this is not possible at all. Why? B does not know A's private key. So then this cannot be done. In that case, then this also cannot be done. So that means this key cannot be used for encryption. So now we have tried 2 keys for encryption. Both are not working. So let's try to use the third key, this one. You will see again, it will not work because now can A use B's private key? Then you have to use the B's public key to decrypt. Only thing is, first of all, this is both ways are wrong, right? The reason is A will not have B's private key, that is you can't get. But then if you are using some key, private key to encrypt, let's say somehow you got it, but in the previous case, you can't really, not somehow, but it's not possible. Let's assume, right? But then still having a public key for decryption, anyone knows public keys, that is also not going to work. So now we can see this is also not going to work. So that means only one key is available now. Let's see whether that we can use that key at least, right? So now I'm trying to put for encryption KB pub. Can A knows public key of B? Yes, no problem, right? So then what is the key we have to use here to decrypt? KB private. Does B know the private key? Yes, only he knows it. Okay, so this is the method now, right? So even though we have key pairs in both ends, right? Look at what the key we have used. So I will just use my highlighter here. Yellow color problem, right? You can see I have used the B's public key. That is this key. Right? I have used the B's public key to encrypt. What is the key I have used for decrypt? B's private key. That is this key. Right? So now actually I have used B's keys only. Right? I have not used send. So sender need not to have keys. Right? Only the recipient should have the keys. But then the bad guy knowing about the public keys, it doesn't matter because bad guys knows this key as well as bad guy knows KP's pub as well. But knowing both, it doesn't matter, right? for the bad guy. Bad guy can't do anything because you need always the private key here of the recipient. So now the theory is you encrypt using receiver's public key. You decrypt using receiver's private key. So this is the theory, right? So you encrypt using the receiver's public key. You decrypt using receiver's private key. No one will be having receiver's private key, only receiver will be having, right? Anyone can send to B because the public key is available. So now with the 4 keys that we have, right, we can see receiver's keys, key pair only we have used, right? Actually, you don't need. So that is why, like when you are doing, like this is how HTTPS works, right? So whenever you log into internet banking, right, you will be using bank's public key. Don't tell me I didn't go to the bank and ask that, right? I never did that. So how can you say that's like I'm using that? Unfortunately, we are using that without you knowing, right? I will tell that story also, like how really it works in your computer. But as of now, I will say, just believe, right? The bank manager called you and said, my dear customer, please take my public key whenever you want to do internet transaction, secure internet transaction with my bank, right? Please use the public key that is here. I am giving you in a CD, right? Or it's in our website, just download it, right? Or I will email you, just give me your email address, right? So there are possible ways, but that's not the way that we are really doing it. That I will tell a little bit later today, right? You will be learning that part as well. But just assume somehow the bank manager has given to you. That is why you are not bothered. Like I'm doing all the security stuff. Like I have never created a key pair. So Dr. Ajanta is just talking about there is a key pair. Receiver should be having, sender should be having, right? What is that? We have never done this. That's true because you need, as a sender, you don't need that. Okay. So what you need is the receiver's public key. Whenever you log in with the DARAS or when you want to log into the Gmail to read your email, whenever you do through your VPN to connect to your office server, right? Always you are using that particular receiver's public key. And that receiver will be using its private key to decrypt. I hope this is, I can't see your faces unless you show your, switch it on your video and show me your faces, you are okay, right? But if you have any questions, please do ask, right? This is the time, like when I do physical also, a lot of people do ask, so is this way correct, right? Do you have to do like that? So all these doubts you can have. This is the theory part. As I said, we have to talk about theory. This is the only theory, right? This particular slide has everything. But if you still have questions, I don't mind clearing up those doubts before we proceed. So this silence tells 2 things. Either you all completely didn't get anything at all. That's why you didn't know what to ask, what sort of question I should be asking. Or else I'm so happy like you all got everything clearly. Now you know the theory part, right?
Sir,
Yes, go ahead.
so to encrypt, it will always be a public key, correct? In any case.
Yes, to encrypt, we use a public key, right? And then to decrypt, we use a private key. Because if you try to use a private public key for decryption, anyone can decrypt. That's what, so that's a good point you asked, right? So like you can remember that way as well. But however, not the other way around. So that's why like you can't use in this, okay, I hope you can see my, yeah, I'm referring here, right? So this point, you can't use a private, okay, what's going on? You can't use a K private A because B does not have access to private key of that particular. So that's always, it has to be B, right? So then with that, if you can remember, then you know, okay, the other key has to be used over there. Yes, you are right. Always we will use a public key for encryption. And then for decryption, we use a private key. Okay. so now I'll clear here. So this note is actually not full complete, right? So that's what I want to, now I want you all to write down here, right? First of all, this is the sender. This is a receiver. Hope you all know that, right? So like, so the arrow is this direction, and you can see the arrow is that way. As well, like, so then here I just put public key. That's wrong, right? Like there is maybe it's just a generic term, but we have to put receivers public key. Right? This is receivers public key has to be used here, right? So this is the receivers private key. Okay. So that part has to be written by you. So I purposely kept it just to understand and write it down without knowing, right? Because that's what, like the story I was talking, there are two key pairs here. There are two key pairs there, but actually we were using the receivers. I put here B here, right? Pub and then the private key of B, right? Or like to say receiver, I just put easy to. You can put here, let's say R receiver, right? Senders ones are not required. So now it's complete. So you get the plain text exactly, right? So all the internet transactions are happen this way, right? So you talk about e-transaction, e-commerce, e-business, right? VPNs, HTTPS, everything. This is the method. Okay, so now more graphical representation, that's you, right? What you do is you use a key, right? And that key is sort of the public key of who's the receiver, right? And the receiver, this is a private key of the receiver, right? So then he can decrypt as well, right? So then the bad guys can't, this is the bad guy is here. He does not know the private key of the receiver, right? Only receiver knows. If the receiver is shared with that bad guy, so then that's why, like we say, you should not like keep your private keys in a public place, right? Or like just post it on a post-it note on your computer monitor, right? So that is not the way, right? You have to keep it with you. This is very, very important. This has to be secret, right? But public key anyone can use. So someone can say, like, so is it possible, so another guy, right? Whenever he wants to send some data, so he will also use the same public key. Yes. So that same public key can be used, right? But then only he can decrypt. No one else in this world will be able to decrypt. That's why, like we say, it's very secure, right? Only the recipient can be able to decrypt that message. Now, keys are like this. This is an example of a public key, right? That's where, like, if you have seen one says that something like this as a footer of that email, just copy paste this. And this is what we call the public key. And this is a private key. Actually, this is a corresponding public key of that particular public key. So this is a corresponding private key of the above public key, right? So then whenever you encrypt using this key, you can use this key to decrypt. So how it works, all behind real mathematics, right? These are, we call big prime numbers, right? So people who have done a maths degree can understand that, or maybe you have studied that, right? How we can do that. But however, in our context, we don't need that. So padlock is something like this, right? That's what, like, I will try my best to find. So that's one key is here, the other key is there, right? I don't like how open and close, but don't, but just like the two keys has a, that's what I want to show, like it's a nicely related each other, right? It's corresponding to each other. There's a tool called Partigen, right? Even I can demonstrate that, but maybe I will do maybe later if I have time, right? but you all can download. This is another exe file, right? Now we know what are the executables, right? This is the exe file. Basically, you can download partigen.exe, and then you can install that in your computer. Right? That's a very simple tool. That tool itself is enough for you to generate a key pair for you if you want, right? So just run that, and then it generates the public key of yours and the private key of yours, right? And then you can save those files, right? And the private key, it will ask, okay, would you like to keep a passphrase or the password protected? Because you don't want to open up so others, because this is what like always you need to decrypt, right? This public key, you can just copy paste and have it on your website that people can download. I'll put it on a footer. As I said, this can be put a paper edition, but I think if you just change 3 to 5 here, right, that's basically that key will not work, right? So because that it's not practical, but however, copy pasting can be done quite well.
Sir, excuse me, sir.
Yes.
Sir, when we do the internet transaction with a particular bank, always the public and private key is same, or each transaction is different, sir?
Each transaction, in the sense like you are saying, with different people or with you?
Yeah, with the same bank. Today I am doing the internet banking with the same bank with the public and private key. Tomorrow when I do the same, the key is same or different, sir?
Very good question. Very good question. Thank you for asking that. Right, I will give you, like, if I can give you extra marks. So that's a very good question. Yes, same pair. So bank and you now. Okay, if I have that slide with me. Let's assume this is the case. Right? Okay. It's not here. Okay, I will. You can have your bank. Let's say you are using bank's public key, right? So that is what always you use. So you have to use, because bank actually has created that key pair. You can't do, like, as a user here, you can't do, you can use only, right? So you will be using the same key. Actually, not only you, others also using the same key to encrypt your data, right? So bank will be decrypted. So once bank created a key pair, that it can be used by all the others as well. So this is very, in a way, economical, right? Because you have to have a one key pair. You don't have to have like each customer different keys. Because that public key, that's why like it's a good thing. Anyone can use the public key and encrypt. So it's you or anyone else with the same bank, you will be using the same key. Hope others got that point as well. So it's a very good question.
Yes, sir.
Good. Yeah, likewise, please do bug me at any time, right? Try to clarify. This is a very interesting part as well, because security is required for you all. And when you are taking decisions, if you know this very well, that you will take the right decision. If not, always people will be fooled, right? Because you are like, they will try to show different other things, and then they try to, like, you might have seen like certain software developers that are talking about even at the COPE, right? So a lot of things have happened because the decision makers are not having the knowledge. That's why like they have not taken the wrong decisions, right? So this we can, this is a very good method as well, right? So that we can now, okay, since you asked that question, so I will discuss that later, but now let's say you have a document management system, right? Each of you all should need a document management system whenever this office, like this is a branch office, this is the head office, right? So whenever branch office sends some document, let's say you are banking or whatever, need not to be banking, just a normal buying and selling stuff, whatever you are doing, right? So some data that you are getting, you can say in the document management, this is not email, this is not web, right? Just a document management system, right? And then you can say everyone should encrypt using the head office public key and send it. So then no other branch office also, there's the bad guy in the one of the branch office. So they will be seeing what this other branch is doing, right? So then he knows how to get the data and read it, right? Let's say he's a more IT guy, right? So then, but if you do this way, no one, even like I can't, right? Because I don't know the bank's secret key, or that is like we call private key. So then there is no way. As of today, no mathematician, no computer scientists were able to predict that private key by looking at the public key, right? So that is because of that, it's very safe, right? So this can be used for so many things, right? Just think of your normal day-to-day transactions, right? You can just implement this very easy, right? And then you get a very secure thing, right? Let's say you are a lawyer, right? Your office people will draft a legal document, right? But you have given full instruction. This is how you should be doing. But maybe one of this guy, right? A legal guy who you just draft is. So they have, they want like, okay, this, they have done it in a subtle way. Like if small, this two words like jumble front and back, right? The meaning will be completely different. So this bad guy, when the document is sending to you, to the head office, they might have like, while it is on transit, let's assume, they have changed those two words, right? So then basically what you as head office, you will be getting that changed document, but you just proceed with that. Let's say this is the parliament in the sense, right? The parliament will pass the wrong act, right? Rather than the correct act that is being supposed to be sent in the proper way, right? So those things can happen. But if you do this way, no one can touch, right? Very simple, right? This, if you had a system just to send whenever you finish the document, just say like upload it to the other side, right? That's a simple document management system. What we say is apply public key encryption technique, right? And then use the head office or the parliament's, right? Public key, and then send it. So then the software here at the parliament, they will be using the private key, and no one in the world, right? Even USA, NSA, Russia, Ukraine, you name it, China, right? Can't break this, right? Because that is safest. That's how we can do. That's how like the bad guys are transacting at the bottom, right? That we were talking about, that dark web as well. So it's like no one knows like what's going on. It's very difficult to trace down, right? So they will be using this technique. But unfortunately, the real people, the good people are not using. They are just keeping it open documents, right? And making it to forge very easily. Okay, that's another thing that I gave you because that you asked that question. So now you can see the private key has to be kept secret. That is by the owner, right? So there are so many other techniques to protect that these days, right? There are some pin protected tokens are there. There are smart cards where like you can put your private key onto a smart card. There are some hardware tokens are available to save your hardware in your private key. So these all to your whatever private key. I put here X here, whatever whose, right? Private key to protect that. And hardware secure model as well. I will just, I think I have a few examples here. Sometimes people put a password to a file, and then if you say ABC 123, that is the lowest level of security because anyone can break that. This is a very bad password, and you should never use that password. But to protect this particular file, right, which has your private key. The pin can be easily known then, right? So these are some, like sometimes you can save it on the smart card, then you can swipe through. Your keyboard will be having a smart card reader, so you can swipe through, then only like it will read to the system, because you are not saving into the system because someone else can take your private key. So you're just trying to protect it, just keep it with you, right? Or you can have some, these kind of USBs, password protected, right? And then you can do that. So there are some HSM, we call hardware secure model, like big banks are using these things, right? So if your IT department, people who are in the banking sector, so you can see that they will be using this HSM, right? So modules, like if they're not using that, So maybe you can recommend, right? We should use this, right? They are dedicated crypto processors that is specifically designed to protect the crypto keys, their life cycle, right? So these are a bit expensive, by the way. So that's what everyone can't use, but very secure document. Let's say you are a military guy, right? So you need to protect your data. So then you should protect through these kind of systems, right? If not, like you all have to have your own way of protecting your private key, right? So now, knowing that, this is a simple scenario, like a user is there. So he wants to send some very secure thing, that text, right, which is very confidential, I would say. Confidential, right, data. So what he has to do is he has to get the public key of the receiver, right? So that he will see a B, right, whoever the receiver's public key. And then you encrypt using that. Right? That's all you have to do and send it. This encrypted file, no one can open except that particular B or your receiver. Right? So then receiver will be able to open up, right? So whenever you encrypt, so this is just an example. If this is a message, you can see when you encrypt, it looks like this, right? Don't say this is like Chinese, right? I think we have some Chinese students as well. I don't know, in this class we have one, but they also would probably say this is not understandable. So this is, in our context, we say garbage. Because you can't, you can read, you can remember I was telling you, you can read, but you can't, can read, cannot understand. This is what we call but scrambling the data, right? So it's like Caesar cipher, right? People used to do that, scramble the data, scrambling the data. So you can read the data. So in this one, this is plain text. You can read, you can understand. Here you can read, you can't understand. Read in the sense, at least you can, yeah, I will say read/see, right? You can see that, right? But you don't know. This is encrypted using a public key. So the corresponding private key has to be there to open. Another good thing, when I was talking this scenario A and B here, so what we did was like here, when we put our data, we put here B is there, no, B is public key, and we got the ciphertext encrypted. Can A read this ciphertext? No way, because ciphertext to read, you need B's private key. A will not have. So even when you encrypt, even the sender can't read it. This is how secure, right? It should not be, because sender should know what you are sending to the receiver. But that is what it happens. Like the ciphertext cannot be read even by the sender now once you encrypt. Let's say for some reason you have deleted the data, your original data, but you have the ciphertext. You can't. You have to ask from receiver to give you the ciphertext, the plain text, right? Because he is the only person who can generate the plain text from this ciphertext, right? So once you encrypt, right, when you delete that, no one can read without having the private key. This is why, like when we read as well certain computers these days, right, due to certain other misbehaviors, like whatever, right? But then even we can't, like police or the sometimes they bring it to university as well for them to get some help to read, but we can't, because what they have done was they have generated all the documents into ciphertext, and then they have deleted all, right, all the data, right, the real data. So then we can see the cipher data, but we can't, because we don't have their key. The key is very big and we can't really assume that, right? So unless we get that person, right, that particular private key, we will not be able to read what is inside that computer, right? So as well, you would have several other mechanisms, right, to get the culprit out, right? Because it's not like technically we can't do that because this is so secure in that way, right? No one can be able to redo of this encryption without having the appropriate private key.
Excuse me, sir.
Yes, go ahead.
Sir, WhatsApp message also the same technology.
Yes, yes. WhatsApp says very good. Yeah. WhatsApp says that they are encrypting our data end to end, right? So they are using this kind of technique. Yes. But I will talk about that a bit later because I'm talking about certain application security once we finish the theory part, right? But since you asked that, yes, they can do that. They are doing that. Okay. So this is what we call WhatsApp security, right? So then messages between the WhatsApp users are protected end-to-end encryption protocol so that third parties and WhatsApp cannot read. That's why like WhatsApp says that, right? By the way, now, okay, I just put this now to explain that as well. So like you asked the right time, the question as well. Now, okay, I'll open a white screen and then explain this. Now, this is you, right? One of you. This is Ajant, that is me, right? So you all are trying to send me a WhatsApp message, right? So when you send this data, right? So then you have to encrypt. You have to use a key to get first ciphertext. That ciphertext is what WhatsApp is sending. But only thing is Ajanta is also a user, but WhatsApp is here third party. I will just put like something like this is WhatsApp, put WA, WhatsApp, right? So WhatsApp generates a key pair, right? From that, they will take the, I put WhatsApp public key. And whenever the ciphertext is going, others can't read. So whenever it comes to Ajanta, the ciphertext, right? So the WhatsApp application decrypt that using the key WhatsApp private key. And then I get the whatever this data. Right? So that is what WhatsApp is doing. This is third party is doing because we never had a key pair, right? To be so specific, right? It has to be generated by Ajanta because Ajanta is a receiver here, right? Ajanta is a receiver. Receiver should generate key pair, but in this particular application, actually WhatsApp is doing for us, right? So in a way, WhatsApp knows the private key, right? So then technically, I would say WhatsApp can read Ajanta's messages. So only you and Ajanta can read, but on top of that, WhatsApp sysadmin, whoever can read because they are the ones who created the key pair, right? But that's why like WhatsApp says that third parties, right? So third parties, anyone and WhatsApp. So WhatsApp is not reading that. That's why like it says, cannot read, right? But if you want technically, there is a possibility because they generate, then they can, right? But they says that this is, I'm taking from a white, but technical white paper means that's what they're the technical paper that they have make it public, right? So that's what. So even WhatsApp says they are not read. So then it's end-to-end. We call end-to-end because this is one end, this is another end. We call end-to-end security means that, right? So you got end-to-end security. So all of the WhatsApp messages, including chats, group chats, images, videos, voice messages, files, and WhatsApp calls are protected by end-to-end encryption. End-to-end means these are the two ends, right? That is Mr. X here in the class and Ajanta, right? Whenever we do a transaction, right? So WhatsApp servers do not have access to private keys of the WhatsApp users. The WhatsApp users have the option of verifying the keys in order to ensure the integrity of the communication. The Signal Protocol library used by WhatsApp is an open source. Okay, this is one of the important thing. So WhatsApp says that, okay, you can have a look, right, what we are doing, right? So that is a library they are using. That library is an open source library, right? This is where when it comes to security, open source is very important. And if I say this is how I'm doing, but if you do not believe me, right, you always do not have a trust on me. But if you just believe me, you have a trust, but it might be wrong, right? But if you can see it with the code, that is where like you will believe 100%. So then to have that source code has to be there. So then open source is a key, right? So that's why like even WhatsApp is using, even though they're a proprietary company, so they are using open source because WhatsApp is opening up with that. Without that, there's no guarantee that. So because of that, probably we can say WhatsApp is also not reading because we can go through the code as well. So that's another appropriate question, as well as that's what I put this slide, right, to talk about a WhatsApp, right? But few other things also I will be talking later. So I think similarly, probably this Telegram is also doing that, right? But let's say when you are doing Zoom, right? Now you can check when you're doing a Zoom transactions, right? Is it secure, right? End to end, right? Is this lecture now between you and me? Can someone else also come and read, right? Unless like I have shared the keys, that is the link for this session is going on, that's a separate thing. But we are saying now I have just emailed only to you all, right? Or I have sent it somehow to you all, right? But then can someone else also can be listening here? Can they get this, right? That is what like, so then that's what like security we are talking about. So end to end means like only those two parties, receive and sender, right? That's like end to end. But then third party in the middle cannot be having, right? Including the service operator. Okay, so that's all theory, right? That's about the private key encryption with two different keys, how we can encrypt. So this is very interesting. We can do all these things that the whole world is now working with that. So if you've got the concepts, you can see it's not very difficult. Now you can apply that not only to whatever e-banking and then your email reading and whatever, right? Just any sending, receiving, right? With respect to any data, right? We can apply that, right? So it's just your emails can be secure like this way, right? So then only your sender and the receiver knows what you are exchanging. Let's say now in your office, there are some organizations, I will not say, I have also gone through recently as well, some cases where if I'm the boss of your company, right? Whenever Mr. X sends an email message to Mr. Y, Mrs. Y, right? Or MBA batchmate, but as boss, I can get a copy of your mail, right? So whenever you are sending, it sends through our mail server, that is you are using the office mail, so then I can keep a copy. And your friend Mrs. Y will be getting that copy, getting a mail, but also I have a copy with me, right? So always now you have a mistrust, or like you don't have a trust at the organization. They know that, okay, they are reading our mails, they are keeping copies, right? But if you use this technique, where you use your Mrs. Y's public key and ask, Machan, can you send me your public key, right? So then you can use that public key and encrypt your mail and send it. So your boss can take a copy, but he will not be able to read that, or read in the sense, understand what it is. Because your boss will not have your friend's Mrs. Y's private key. So that's how secure, right? So if your organization allows you to use private key, public key in your emails, we call secure email then, right? Secure email policy. So then you can do that. If they are, so if I am saying, okay, my employees, you can use secure email within our organization. That means I don't have any trust, any issue like, and I can't really read your mails because you will be using other person's receivers public key to encrypt, and then I don't have those receivers private keys with me to read that, right? That's why, like if you look at Gmail, Gmail is not supporting that feature. So that means all your mails are kept plain text, right? So the Gmail or anyone who can access to Gmail can read your mails, right? So if you're using that for certain private transactions and especially very critical things, maybe these days ministers are talking each other certain things, right? But probably that's not the right way to do, because others can read your mails. So that's important, right? So now if you got those two simple points, I think you can understand that. Okay, now I'm going to take you all to a different direction. Just we talked about with a single key, we can do communication, we can give some security, but only thing is sharing between them. So now here the most important thing here is, let's say you are here in Sri Lanka, there is a merchant, right, in Russia, but you have never met this guy, right? So there's no way like you can exchange this key with him, right? And you don't have like it's like Alibaba or like something, right? So then you don't know them, right? But then you want to do a secure transaction because you want to send you a credit card because you are going to buy something. So your credit card number has to be sent in order to do the transaction. But then you can't give the public key first. This is a private key. Let's use this key, right? Single key, we can't. So what we do is we say, okay, give me your public key, right? So get the public key of the merchant. I put the M of the public key. You can download that and now encrypt, and then the merchant can read that. Then they will do the transaction and say, okay, thank you. The note will be coming and the goods will be coming later on, right, to you. So that's how it works. That's why like we need two different keys, public key, private key, and that's we call public key encryption, right? Another secret key, single key encryption method. So these two techniques are different, but the first method is very fast, but unfortunately we can't use it for internet transaction. Second method is very good, but it's pretty slower, right? That's why like we can't give like extreme security. We are giving huge long password, long key rather than say password, right? Long key, because processing takes some time. So people came up with another thing, right? Combining these two, combining public, private keys, right? And then going ahead. So that's like these two methods are not competed as each other, right? So then let's see like how to do this. Initially, you have to use the public key encryption. So what we do is, this is B now, this is A. So I will say, you have a secret key, right? I will say key means secret key, right? This is you having, right? What you can do is you can encrypt that with a key to get ciphertext. That key is this person's public key. You can use the KB pub. So then this key can be, the ciphertext can be decrypted using B's private key. B can do that. So he will be getting the secret key. Now B is having the secret key. So now we can use the secret key, right? So now instead of this public key, private, we can use secret key for communication. Only these two will be knowing, because this cannot be decrypted by anyone. Only B can do that. That's why like it's a compromise now between these two. Right? So that is what we call a session key, right? Or single session key, right? So the session key concept comes with that. You have to use first two keys, right? Use the receiver's public key and encrypt your secret key and send it. So then the receiver will decrypt using his private key and get that special secret key. And then thereafter, it can be used, right? So these are we call session keys. So we are using session. Sometimes when you're doing with banking as well, in your bank, so they will generate a session key between your browser and the server. And then thereafter, the session key will be used, right? So the question that someone asked earlier. So of course, yes, you are using the same public key again. When you, let's say after half an hour, you are trying to log in again, right? In that case, you will use the same public key, but you generate a different session key and send it. The session key, as the name says, it's for a session, right? Some people say, like, if the session is too long, within certain, let's say 2-hour session, every half an hour session can change the password. How? If I go back here, whenever the receiver wants to change the key, remove this key, put the secret key 2, and then send it. And then he will be getting secret key 2. So like next half an hour, it will be used that, right? So likewise, that is possible. But technically, the session key is for a given session, you use 1 key. So whenever you're doing internet banking, probably you will be using 1 session key for a morning session, like when you 2 p.m. again, when you log in. So you are using the same bank's public key, but then the session key is different. So thereafter, the communication probably handles the session key. That's why, like, through that, we can get that disadvantage of the time factor, because I said 2 key processing takes a little bit more time than the single key. So then we can take the advantage. So if I ask in the exam, what is meant by a session key? So this you should be able to explain. Session key is nothing but it's a single key. But however, to exchange that, you have to have 2 different keys. The public key cryptography has to be used. By using receiver's public key, you should exchange that secret key with the receiver, and thereafter you can use that. So that's what, if you can give that, you get full marks as well. The same thing is here now, right? So we can see once we do that, after that, we have a single session key, right? That is for a certain time period, I can say. Sometime, right? Only for this session, right? That's what I can say. You can generate again. Okay, so that's another method, right? Where session keys stuff, like it's very easy. Now, if you know both ones, it's just a combination of that. First, we have to start with 2 keys and then you move to single key. Now, this is a completely different thing, right? I will tell, first of all, before coming here, why we have to discuss this, right? Now, actual security is over, right? So we have finished security theory. Everything is over. Now, all applications, we are going to look at it, right? Now, get this scenario here, right? So let's take 3 people now. A, B was there. Now we'll get another guy C as well, right? I'll quickly write K, A. Yeah, these are my notations. Like in the exam, I might put pub up and A down. Don't worry, right? Maybe I will try my best to keep it like this, not to confuse you all. But if I say K pub A, but the up and down is wrong, that's, don't worry. It's K pub B, K private B. Let's see, you also can have T pair K pub C, K private C. Okay, there are 3 parties here now. First one, second one, and the third one. Okay, now let's see, there's a transaction is going to happen this way. Some data. This is the purple color data going on the purple color direction line, right? A is sending to B. So now I will say this will come to the decryption algorithm, right? And you get the ciphertext. Then what key we have to put, right? I think we discussed that, right? That should be the receiver's public key, K pub B, right? And then you know the rest, right? Okay, I'll write down that as well. Okay, it's the same color. So then you get the ciphertext. You put the description algorithm to get that data, right? And you will be using this key, that is the private key. Okay, so that's what happens. Now I will take another scenario. Now, can you all tell me this? This is another transaction, another customer, right? Wants to send another different data, okay, green color data. And then that has to be put into decryption and create the ciphertext. So what key I should be using here? Because if the recipient is the same recipient, so we have to use recipient's public key. Recipient public key, right? And then again, the recipient will decrypt the ciphertext. Oops, oh, that's a bad thing. Do the same thing very quickly now, since we discussed that. So then this, I will say DA, data A, right, will be sent with encryption with this key, and then you get a ciphertext. Ciphertext, and then you put to the decryption, right, and you get the whatever DA data with this whatever key. So here we use K pub B. Here we use K private of B, right? Now here also we do same thing, DC data C, right? Will be sent to this encryption to get ciphertext, which we will be using same key. Recipient is B, it's public key, and then the ciphertext of the green color will be decrypted and get the DC data, and then the key again to be used here is KB private, right? So that's simple. Like the B will be using the same key, right? Now there is a small problem with this. This is how you do internet transaction, right? This is what we do have internet transactions communicating like this. But is there a way for B to know when a message comes to B from whom he got it? Because both will be using the same key. Because of that, there is no way that we can guarantee, like data will be there, right? But someone can say, sir, the data is different. But however, how do you know? Like, let's say, maybe A guy can pretend like B. Let's say this is a bank manager. These are this is the head office, right? Your CIO. These are the two bank managers of the two same bank, two branches, right? So this manager is not really good with this particular person, right? But he can send a message to manager pretending like it's been sent by C, because just like you can write a letter, right? I'm going to kill you, I don't like you, right? Just whatever threatening mail. And then you can say this is a signature of like, this is the manual document, right? So put somehow the C's, right? Signature, right? And then now he encrypt, just that makes a DA. And then encrypt and send it. Then securely going, right? No one can touch this, right? This is securely coming. Only thing is this is forged now. But then the CIO here has a problem. Actually, who has sent this? Is A or actually C? Right? It looks like it says C, but I don't believe C is a good friend of mine, but A is a guy, culprit guy, right? So that's, but only thing is he can't take even legal action because he can say that I got a secure message, but it's not like I can't specify who the sender is. Like we can't authenticate, right? Who the sender is. So this is a problem, even though we use this technique. It's authentication. So then people try to find a solution, right? So how can we make sure, how the receiver makes sure that it is actually coming from this particular sender? Then we have to have something special about sender, right? Speciality of the sender. How can we do that? One specialty we can think of is each one has a key called K private, but A has the private key of A, right? And then this guy also has a private key, KC private. Is there a way that I can make something from that important special key, right? That was like people wanted to have, right? And then they were looking at some mechanism to use this 2 different keys for this sending and then to get a solution for this authentication problem as well. Then if you send a document, you are legally bounded that you have sent it, that you can't deny later. This is we call non-repudiation, right? Thereafter you can't. That's why like even today in banking sector in Sri Lanka, we are not using that. That's why you can't send an email to your bank manager saying, please deduct 100,000 from my account and transfer to Dr. Ajanta's this account. You can't do that. Banks will not accept your email because bank manager can't trust who is sending this email. Is it really that my customer? But then you all say that, but we can do it on internet banking. That's what, first you have to log into the internet banking. From that you can give, that's why like you can send emails from that interface because then they know that this is so-and-so is logged in because we have given this username, password, one-time password, everything given to this particular user, right? So once you come there and give an instruction, bank will take it. So bank doesn't say that we are not taking email instruction, they are taking, but they have to make sure, they have to verify that it's the right person is sending. If not, like this is all money matters. So that's why like when you log into the e-banking portal, you can give instruction that will work because you are being authenticated by that application. But if you just use your normal office mail or Gmail and send a message to the bank manager, they can't take it seriously because the bank manager can't authenticate. But if you do this method, yes, you can do that. You can give an instruction to the bank manager. Hey, I'm so-and-so, let's just send it. And the bank manager can verify that's the right person. Only he can do it. So then he should be able to do that, right? So this part is not really even available in banking sector, right? But then you can ask where it's available. Yes, there are places like in your, again, document management systems, like when you develop systems, right? Your ERP solution, yes, you can do. This is like we call fully secure, where you can authenticate the sender as well. The previous method, we are talking about sending a data securely to receiver. That is what our purpose when we did it, right? So don't think there's a mistake on that. No, right? We were able to transfer it securely to the receiver. But now we are talking about something else, like how we can make sure that this is the right sender, right, to take an action. It's like you are getting an email from someone, can you do this favor to me? But one thing is you are not sure whether the right person is asking the favor, right? But if you do this way, yes, you can. So in your internal systems, this is very useful going to be, right? So when you're doing some, what do you call this, standing orders, right? So who is sending the standing order? like instruction, and then based on that, you can take some bank branches. When you are communicating, you can do quite well rather than real customers are coming into, right? So with your systems, so you are using, some of you are using this method, right? So this is like in manual system, how can we say like whenever you write a letter, right? This is manual, I think, manual system. You write, and how you verify it's you? You have your signature, right? So the signature is there. Today we call it's a if it's a legal document with a signed document. That's why, like, if others can put your signature, you have to be very careful. Dangerous. Like there are some people do that, right? You have to have a very good, difficult signature, so others can't do it. Only you can do it, right? But that's in manual system. So in IT systems, so how can we do that? Yes, we can do the same thing. So then we call it's a digital signature. So if we can have a digital signature, by the way, this is not the scanned image of your signature. That is, we never call that a digital signature. Please, from today onwards, don't call that as a digital signature. Say scanned image of your manual signature. That's the right one, right? At least you can say scan image, right? Because digital signature is completely different thing, which I'm going to teach you now, right? With the help of these keys, right? Senders, private keys. Okay, so that is what digital signature is, right? A lot of people, I know that even in our university as well, people say, sir, digital signature is wonderful on the document, right? So I will say, okay, but they want that my scanned image, right, in that PDF document, right? And then we do that, but that is not the right way to do, right? There is a proper way in IT systems to use digital signature. So then I will show you later how secure is that compared to this manual system. Is that requirement clear to you all? Any questions? Oh, everyone is not clear.
Yes, sir. Yes.
Okay, good. Thank you. Okay. So that is what. So now we have to talk a little bit of theory to implement this now, right? So this is the scenario. This is the case study that we are trying to tackle now to give an IT solution. And with that, basically, that's 100% what we can do with IT systems. And this is the securest way that we can provide. But again, not 100% secure, because anyone who can predict the private key by looking at the public key, everything fails, right? So it's not been failed as of now, right? So then I'm saying I can teach you this theory, but yeah, there can be a possibility, like it's very, 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 very rare, right? As well, like some people say within double quotes, impossible. But now what we are trying to do is, that's what we are trying to authenticate or trying to identify who the sender is also, right? And that's the best way you can have systems. And even like in digital transactions, it's not there. That's why, like now in that case, both parties should have the key pairs, right? So now here, sender also should have a key pair in order to do this. That's where, like, this is practically not easy to implement with the users. That's why, like in the bank customers, we can't do that, because then each customer, you have to do a lecture, right? Or you have to invite me if I have done the job well, right? Explain the importance of this and how to work with it. If not, it's basically how to like basically create the key pairs, because earlier the user need not to know, only the merchant or the receiver side has to do that. That's your bank or the Alibaba or like your company, whatever, right? So then we can create that. But here it's not possible with end users, but of course within your organization, in document management systems, your ERP system, right? Your fingerprint, whatever based something, right? So all these systems we can do that, right? But taking to the clientele and making them awareness, it's still, we are not up to that level, I would say, right? With the users' knowledge, but you should, right? As MBA students, as well as people who are going to take the leadership in the future, you should know how we can use that. So that is what I'm going to talk. So,
So,
yes.
So is there a difference between the electronic signature and the digital signature?
Yes, yeah. We can say electronic signature is that scanned image. That's what I use the right term. Manual signature, scanned image is the right one. But digital signature is, I think you should never speak, never interpret your manual signatures scanned one, digital signature. That is wrong, right? But you can say electronic signature also, but it's really electronic signature should be this, right? But slowly we have to move, right? Because that is a scan image. That is like, it's just a manual system. We can't really use to prove anything, just for visual, right? This is Dr. Ajanta's signature. That's all, right? You can do. There's no other thing we can do with IT systems with that scan image. It's just a illusion only, right? From IT system, we can't do anything, right? But in a manual system, we say that is legally accepted. So when you take a printout of that, we can make it legally accepted. But not as IT systems, it's not legally accepted, that scanned image, because just it doesn't give us anything. Okay, I will take about 10 minutes break and then continue, right? So what's the time now? It's about 10:05, 10:03, right? About another 10 minutes, like before 10:15, like 10:13, 10:14, like we will start. So give me about 10 minutes break. But if you have any questions, you can still ask. Right, so in order to have that digital signature, right? So let's cover some theory that are required for this. So now message digest algorithm is a technique that is required to create our digital signature, right? So that is why we are talking about that topic. So message digest algorithm is nothing but whenever you have a message, we call a hash function, right? And it will create a digest, a kind of a fingerprint. Maybe just you can think of a number, right? This is a document. This is a Word doc file, right? The doc file, when you put it, this is the function. This is like a program, right? And it produces a digest or number, right? A fingerprint, which is not encrypted, right? So because a lot of people think this is an encrypted thing. No, this is just a plain text. Plain text digest, right? So this digest is plain text. So this message digest algorithm basically maps any variable length message into a fixed length output. So always that whatever output is, whatever fixed length means, let's say it's 100 characters, 100 character, some number. This character number, like it can be like A, B, C. This number need not to be all numeric, right? Maybe something like that. So there can be, let's say 100 characters, right? That's okay, right? It's really not 100 characters, but just let's say 10 characters, right? Easy to understand, right? So that is what it comes. So all, whatever the size, like it's 10-page document or 200-page document or like 1-page document, always you get the same digest size, fixed size digest. It is not feasible to determine the original message based on the digest. It's like one-way function. Whenever you put a document and you get the number, so there's a algorithm here or program, then you get the digest, right? So this direction is okay, but there's no way you can come back. By looking at the digest, you can't say this is the document, right? So it's a one way. That's what I say here. One way only. Okay. It is impossible to find an arbitrary message that has a desired digest. That means you can't create the digest. I need this number to be there, right? You can't create like that because it is coming from the algorithm. Just no one can predict, like you can't really make your document to come like that. It is infeasible to find two messages have the same digest. If there are two documents, right? These two documents will always have two different numbers. So these are the things that are required. So that's a mathematical thing, mathematical equation. So don't worry. So hash function is a program, and then the message digest is used to create a unique digital signature, right? Okay, that I will tell you how we can create. So this is what we are going to teach now, right? But however, message digest is not a digital signature. So I would say this is not a digital signature. And this is also not encrypted. Both, right? Not. This is more like you put here into a some mincing machine, like if you put meat, right? You get mince meat, right? You can't put mince meat back and get the meat, right? So it's like that, right? So you just have one way direction, right? So you can't get those things. So there are some algorithms called MD5, SHA 1, 2, 3. Can you remember when I was talking to you all about the public domain software, right? I said SHA 3 is also a public domain software, right? So there are some examples. Just for your information, I have put some examples, right? MD5 algorithm is very popular, but it has some issues. But then SHA 1, 2, 3 are much better. Now, for example, see here, this is a message I'm putting. This is a test message, ... right? So then when I say hash it, MD through MD5, this is the hash actually I get. This is the actual example. If you really want, you can go to this URL and try this, right? And then this has a specific number of characters are there, right? So actually the length, we say number of bits, right? Used to represent these numbers, whatever, right? And now what I do is I do the same thing. This is a test ... only 2 dots are there. So here 3 dots are there. So just what I have done was just change 1 dot from that document, but you can see the numbers. It's 2 different numbers, right? So this is the death number, this is this. So both have the same length, but different numbers. So that means whenever you put into the MD5 algorithm or the hash function, it generates a unique number for that particular document. That is all it does, right? Nothing else. And this is readable, kind of understandable, because this is not garbage, right? But this is not encrypted. And this is not a signature as well. Now let's talk about what is a digital signature. So digital signature is used for non-repudiation. What we call non-repudiation is you can't deny it's not you, because once you put that, basically you caught up, right? So it's like whenever you start sending digitally signed emails, and later on you can't say I didn't send that, because you have to send it, because if the other side can verify it's you, that it's basically legally also you caught up, right? To make the user becomes unable to deny, right? That is what. So then how to create the digital signature? These are the steps, right? Let's try to discuss slowly, right? It's not very big. So first you have to create, let's say you have a message now. So you have to have some source document, right? Something to be, get the digital signature. This can be, just think 2-page, right? Word document. Or you can think this can be your credit card number, right? 4505, whatever, right? Which it's a credit card number, right? So this is what you want to send it, because this is the content that you want to send to the receiver securely. That's one thing. But then we use that itself to sign the document as well. So this is digital signature, is completely different. It's not like the signature we used to draw our signature. Okay. So we have to use the same data. So this is the same data that we want to send securely to the recipient or receiver, right? That's what. So I'll take that data, first create a digital, so message digest, right? So then you got the original message. We put the hash function if you want, right? Hash function, and then you create a digest. That's a fixed length. Some number will be generated. So this can be example MD5 algorithm or SHA3 algorithm, whatever. Right? So that's what, like, when you apply that, you get it. So these are all public algorithms, right? You don't have to pay someone, give me SHA3 algorithm. That basically these are known, like these are available codes. So then usually done by hashing it. Okay, then MD5 is the message digest algorithm. Yeah. So then we get the message digest. So we call MD. So I'll call here MD. MD stands for the message digest, which is coming from the original document through MD5 algorithm or SHA3. I'll use always SHA3 because sometimes people get confused with MD5 is an algorithm name that used to hash this. MD is a message digest, right? When, like, with the 5, like this is a version 5 actually. This is message digesting version 5, right? But then when I write it SHA3, then you know it's something different, right? Because sometimes people get confused if MD, they try to put MD5 here as well. It's wrong, right? MD5 is an algorithm, right? Message digest is the fixed thing that we are getting out of that, right? Now here we create the digital. This is the slide actually, how to create a digital signature, right? Encrypt the message digest, that is MD, with the sender's private key, K private, whatever, now let's say A and B, A, which only the sender should be able to do that. That's right, because we know that only A will have his private key. So now only the encryption happens, right? Remember. So message digest, we take it. This is, I will say, plain text. But it's a number. How did it come? It came from the original document. ORG doc, I will say, right? Original document provided you this document. Then it created through SHA3 algorithm, and then you got the MD. That's a plain text thing. MD is being encrypted now with sender's private key, right? I'll put here K private A. And now this is what we call digital signature. What is this? This is an encrypted message. Right? That is what digital signature is. So there's the digital signature is always depends on the document. So if you have the credit card number, you have a different signature. If you have a 2-page document, Word document, you have a different, because this is different, then the MD will be different, MD will be different, because this key is same, but then when you encrypt, you will get a different. So remember, digital signature is different per transaction, per document, whatever, like, so that so each time whenever you add a digital signature means it's unique, right, to that particular instant. So it's not like your normal manual signature. That is always, it's common. That's why, like, sometimes some of your friends know how to put your signature, right? Especially towards like when you do have physical lectures attendance, right? So then that's not the way, right? So it's not like, so then it has to be different signature for each and every transaction. So then, so this is the slide, right? So then if I ask what is a digital signature? Digital signature is an encrypted message, encrypted by the sender's private key. Good. It encrypts the message digest of the original message that you want to send, right? So, or else you can say, whenever you have original message to be sent, create a message digest and encrypt that with the sender's private key, and then you got the digital signature. So once you got the digital signature, this is what you have to do. Add the digital signature to the plain text message. So This is the message. You have to add this, right? And then I'll take you. So I'll take another white screen. Sorry. Let's take A communicates with B. Now, since you all know each case, I'm not going to worry too much. So this is the doc that you want to send, right? Plain text, data, right? So then you have to do a few steps initially. Okay, earlier what we used to do was, okay, we'll do that step now, right? You got the data, capital D, data, then you data, you encrypt that. Receiver is B now, public key, oops, sorry. Oh my God. You encrypt with B's public key, you get the ciphertext, okay? And then you did other things, right? Now, this is what you used to do, to first encrypt, right? And I will write it decrypt also here. CT, you get that, you put the decryption, and then you put the key of KB private, and you got the data. Right, so these are the steps that we were talking about. So I'll keep the blue as it is. Now I'll talk about with green, the digital signature, I would say DS, right? What we have to do is get this data first, apply to SHA3, that is whatever the message digest algorithm. You got the message digest. This is also a plain text. Now what you do is you encrypt that with, I'll write it down this way, another key. That is the key A's private key. Okay, now I'm changing that now. Key A private. Okay. And then what should I get? I should get the digital signature, right? This is encrypted because once you encrypt, we know that when you come through E, this is a ciphertext then, right? Actually, this is also ciphertext. This is the document ciphertext. This is the ciphertext of the message digest, right? With the different key, right? Digital signature. Right, now we have digital signature. Now what it says is, okay, so these are the new steps. I will take now the red color, which I have not used. Now, instead of getting data, now this step has to be stopped, right? Not doing like that. First, we do that. This is number one step, right? Second step, I would write it here. That is, you get digital signature that you got it from here. And add the data, both. That has to be put here with the same key. Now you get a new ciphertext. I put here ciphertext dash whatever, right? Because that is what. Then the receiver side will be getting ciphertext dash, and then you get the decryption with the private key. But then what you should get, not only data, data plus the digital signature. Okay. So this is the steps, right? even without looking the receiver side, I will redo that. So whenever now you want to send a document, digitally signed document to the other side, what you have to do is, this is your data. First, you will do the first step is to this one. Get that data with the SHA-3 or hashing algorithm. You get the message digest, which is plain text. Encrypt using the private key of the sender and get the digital signature. Now you do the same step, like get the digital data signature plus the data together. The whole thing has to be encrypted with the receiver's public key, and then you get a ciphertext. As I put ciphertext dash because that's now ES is also been added compared to the previous step. So when you now look at the receiver side, that ciphertext that you received can be decrypted by the private key of B, but then you get two things. So data can be read, but now DS is again another ciphertext, right? Actually, this is a ciphertext. Ciphertext will be again another encryption. So double cipher is, so that's like some people call this is double encryption, right? So we are using double encryption standards. Exactly, this is what, right? So if someone comes and try to tell you something, right, to tell that, okay, we are doing very much the state of the art stuff, like we are doing all your document management systems, double encryption, right? So double encryption means because DS is encrypted already, then that with the data again we encrypt, right? So again, on the receiver side, if I just put a line here, right? The first step would be like to decrypt with the private key of the receiver. You get both. Now this is all right, data that you can read the data, but now digital signature has to be decrypted again. Now you have to check what's the key. Now only we know, okay, I am trying to put a key which is called KA pub, which I can do. I am B. But I am putting A's public key. And if I get some, say, what should I get? Actually, I should get the opposite of this. That is the message digest, original message digest should get it. It's a number. If I get this number, I know if, let's say, if I have a number, I know it has been decrypted correctly. If not, it won't decrypt, right? It will give a message, right? Then I know that I put A's public key. So then A has to put his private key to encrypt this. That's how like we guarantee, right? In the legal terms also, we say that A has used his private key. Only A can use it because of that this document is coming from A, right? But that is the second step of this discussion. But the third step would be, now you have a number, but how can you say that is exactly that same number? Now you got the data. Now you do repeat the work. You get the data that we did earlier, put SHA-3, and we get the message digest, a new message digest from the received data. This is, I would say here, received data, right? When you put received data here and put SHA-3 is a common algorithm, I would say public algorithm. And then you got a message digest. Just here, I put here MD dash, right? Or red MD, purple MD. Now my fourth step, I'll write it here because I don't have enough space. If MD equals MD dash, then I can confirm, because with the message digest theory, I said a given document can always generate that number. A different document, even if a dot is removed, you know, it's a different number is coming. I showed you with an example. So that means this is exactly same document that is being used to create the message digest that I received through the digital signature. These two are same. So that means this is the exact data that my friend wants to send me. Nothing was updated, right? Because if something is being changed of the data here as well, so then, because if you are using the same data to create this digital signature, and then you just like while you send, you just tweak some data here, but then we can capture that, because whenever in the third step, when we create the digital signature from the received data, you will get a different message digest. And then step 4 number step number 4 will not be equal. So you can see this is a very good security where not only it specifies who the sender is, it guarantees that the data is not being touched. This is we call integrity of the document is also maintained. So if you do this method, you can send securely documents to a receiver without giving any allowance for anyone in the middle to tackle that or read that or try to capture that, right? Then the normal security is there. That's what like first security we talked about, right? That is with two different keys, how we can allow the security. Then we try to use the digital signature mechanism to add the sender's identity using his private key. And then we were able to tell that, because with the second step here, the receiver side, the second step, whenever you use the public key of that sender, and if we get a number also, we say that if it works, right, we know that he has used this. So that also tells. But now since we do the third step as well, because we use the received data and create the message digest, and the step number 4, we compare that with other, and that tells that this is not being touched at all from the sender to the receiver. That's why, like I was telling earlier as well, the subject minister will create the act. Let's say Minister of Tourism will be coming up with a new act to be adopted by the parliament. But let's say he has done with his consultants, and then he has sent this document to the parliament secretary. The parliament secretary have to table it, but let's say they are doing manual way. But then someone who wants to do some bad thing, right, or like tweak this act in a way that appropriate for him or her, so then he just do some tipex or change something, right? A comma will be removed, right? That's, as I said, then the legal interpretation might be different. So he might have found that that's the best way to do that. Let's say somehow, I'm not saying the parliament secretary can allow that to do, but just assume it is possible, because just I'm trying to show you a case where the possibility. So then, or let's say he has forcefully or like without the parliament secretary knowing, when then put some tipex on that. And unfortunately, then parliament secretary asks his staff to take 225 copies and give it to all our members. And then everyone reads that and they put their hand up and down or whatever, yes, no. And then finally, let's assume with the majority, it has passed. Then what is being passed is the forged document, right? So then that is going to be the act, right? Unless later on, after several years, someone found that this should have been, then that by that time that Minister of Tourism can say, no, that comma was, there was a comma, so something has happened, but this too late now. So like already has gone. So, but that will, if you, let's say, I have asked all the, so I'm the president now, so I will say everything has to be electronic documents. So if the tourism minister send that document with his digital signature to the parliament secretary, right? And then basically nothing can be touched, right? And then let's say like, even like when you print also, you can do that. The same thing can be done it for our passports, right? We know that when the data is being collected, right? The passport data, the name, age, address, everything with the photo. And you know, like in the middle, as the file goes on, certain things will be changing, either the photo or the name or like the age, whatever, right? And then finally, a proper passport will be printed with wrong data. But if you start with the right process with this technique in, and then before we print, we can make it to check. And it has to be the same data, because if not, the digital signature, whatever the printing side receiver, right? We can verify if some data is being manipulated, because when we create from that received data and the original data, because let's say like that is where the submission has happened, right? And then we can verify that and we can stop that printing, right? Because there is some manipulation has happened within that document, which is received by the printing department, because with the original digital signature, there is a mismatch. So these things can be nicely done and implemented, and all these malpractices can be stopped very easily. So that's where like digital systems can bring us a very great security compared to the manual systems. So these are the same thing, the note. Now I'll go quickly. So if I start from here, I said, okay, I'll clear up all this garbage now. So once you create the digital, just once you create the message digest, then you get that and encrypt using sender's private key, you get the digital signature. And now add the digital signature, digital signature to the message that which we did, I showed you, right? And then this is where like we adding both, right? Now the whole thing will be encrypted using K pub of B, right? Receiver's public key. But if you have a session key, you can use a session key. So I have put here O here, right? This is also possible. If there is a session key between the sender and the receiver, either session key or receiver's public key. Now the receiver can use his private key or the session key, right? And then decrypt the message. And then he can hash it and get the message digest, right? Again, because from the digital signature also we got the message digest because we use the sender's public key, right? And then we can get that. Now when we compare these two, if these two message digests are matching each other, we can authenticate. But then not only that, we can talk about the integrity of the document as well. That is coming as extra advantage than what we are expected to do, right? But that is possible. So this way we can have the digital signature summary like now I think I have explained to you all. Digital signature is very good for e-document. That's why like today we don't use for even online banking and stuff like that yet, right? And then it varies from each time. The digital signature is not a fixed one. And also like the public key of the signer is known. Anybody can verify the message by the digital signature. So if you take it the paper-based, authenticity can be forged here, cannot be. Integrity, signatures depending on the document, right? That's where like, so then some people can forge to put that document, but here you can't, right? And non-repudiation, handwritten experts and error prone that you can, especially like people can use the same way, right? But here it's not. So electronic documents, I would say, is the safest method compared to the manual paper. So if someone is still believing that manual based, paper based method is the best method, that's wrong interpretation, because manual based has a lot of ways to forge. That's where like people want to have them. But if you move to an electronic environment, we can pinpoint and we can check all these errors very easily, right? So because of that, I will declare here, right? Electronic based document management system, electronic based, whatever transfer systems is the safest compared to the manual systems, right? There was a circular in 2013, right? When Mr. I can't remember, President Secretary was, I think, Mr. Lalit was that, I think he's the one who has issued a circular, use of electronic documents, electronic communication for office use. I think that's if you have time, right, try to download this circular. If you are a government officer, you should be knowing, but even the private sector, right? The circular number is here, right? And then it just talks about everything, right? They sending digitally using normal public key, private key, and as well as using digital signatures for communications, right? But unfortunately, we are not using, that's a bad thing. This is in the recently I saw in the paper advertisement, right? Just I copied that. This is like just I removed like all the companies. So protect electronically transmitted documents, blah, 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 blah. So they were talking about it. This is just soon after COVID, right? This advertisement was there. So prevent your signature being copied and so that whatever said like so they were doing in marketing. So I was a bit happy to see that. And then I thought I will add to my slides as well. So that's this is a Sri Lankan company, right? IT company just trying to promote and digital signature based document, right? That's an advertisement I show. Okay. One last thing, right? With that, probably we can finish it off like all these things that we have. Because digital signature is the sort of like a bit of a longer process because both side keys are required, right? Remember, sender and the receiver both have to have key pairs. Without that, we can't do this, right? Because initially get the digital signature, we use the sender's private key. And then to send that securely, we use receiver's public key. And the receiver side, we use receiver's private key to decrypt first. And then we use sender's public key to get the digital signature out and get that message digest. And then only we compare those message digests and the created message digest from the received data. And then we made that observation and conclusion that this person has sent it. Now, this is what you were doing, right? I will tell you that story. So I will go back to that example. This is when you try to log into an e-banking, right? This is you. Now you say, I want to bank, let's say, bank of whatever, right? This is your bank. So what you did was you open up your web browser. You just type the URL. Now you know all these things, right? And then you just went there. That's what I didn't have any keys, right? Okay. This can't work, right? So then whenever you log in with the URL, so you get something with that. What it says is, please log into our system, right? So once you send the request, I want to log in, I want to connect to the bank of whatever portal, right? So then the bank will give you a page and then it asks you to log in. So then you have to put your login ID and the password. But now this has to be securely sent. So then how to do that? You have to encrypt this data using bank's public key, right? But you don't have it. You said, I don't know, right? Don't worry, right? Your browser knows how to do that, right? So your browser will say, there's a third party here. I say, third party, right? There's a third party. I'll tell what is the third party. So I'll take a different color now at least. So now when this comes, the bank will go to the third party and say, can you give this particular bank's public key so that they have K bank now pub, right? So they will give you that, not to you, to whom? To the browser. Now the browser will take that public key and now encrypt use with your data. So your data is this, right? So this will be coming and now the ciphertext will be going. That's how it goes, right? So this is all make it transparent to the end user. So end user need not to know anything about security, but only thing is they have to know the right URL. That's where like we say, use HTTPS. If you do not see a padlock, don't do that. That's what we can tell dumb users, not like MBA students, right? Any dumb user. So MBA students now should know exactly how it is working. So the browser will go somewhere from a third party, brings back, right? And then it encrypts and sends. That's where like it takes a little bit of time. Right? This is where like I said 100 times slower, but that slowness is not that 100 times in milliseconds, right? You don't really much notice, right? But we don't want to make it that like 2 seconds, 10 seconds, 20 seconds, 100 seconds. That's too much, right? That's what like we should not increase the keys, like not you, the bank, right? The bank is trying to say like instead of like today, I think they use about 512 bits keys. maybe 1024 bits keys, maximum 2048 bits keys. You can check this, right? So this is there, like whenever you see HTTPS, right, on a padlock, just click on your mouse, you will get some information. It says about the key, and then you can read a little bit. I think I can remember what exactly you have to type. Click on that, in that area, you should be able to. It says some properties or whatever. Right? When you take that, you can see the key length, that some key won't be there, but if you want, this is a public key, right? You can see that, but not the key details probably, but generally the key length, everything will be there. So just if you have two banks, we are doing internet banking, you can check the sizes of the length, and then you can see which bank is more concerned about security with the key length. Right? So that's why, like, let's say this is the standard size. You should not make it like 100,000 bits, right? Then only like it takes about like 10 minutes or like 200 seconds to process this, and then it is too late, right? Okay, coming back. So whatever the key length, it all been done by your bank, and then it comes. The bank has bank web server now. You go talk to the web server now. Web server. So web server has the private key. Don't go and check that. You won't be able to, because that is, they have securely put that, right? So that's how like they are opening it. That it allows you to log in, and thereafter it allows you to do the transaction. That same thing Gmail does. Same thing any HTTPS does, right? So that's what like we call. So this, what you get is called a digital certificate. So what you get is a digital certificate. The digital certificate is being used by the browser to get the public key. That's what you don't need to know about, or you have never been asked from your bank manager, what is your public key? Okay, let's look at the theory. So the potential problem is public key is a thing, and then sender must know the receiver's public key. So then we use trusted third party, we call TTP, trusted third party. This is what we call a certification authority, or CA, right? So they will keep certain users' public keys, right? And then that has been encrypted by the CA's private key, right? So that is also being securely kept it, right? So CA's public keys in our browser. That's how, like, if someone asks technically how you get it, right? Because CA's public key is in your browser. It's hard coded by the browser, right? By the way, this is kind of another business, right? Because that's where, like, no one, like, everyone can't be a CA, right? You have to be recognized by the browser, because if not, this, like, if you do not have the CA's public key, you can't go there and get it the public key of that particular company, right? But without going that detail, right? Just I will say the CA is a entity that we call, right, in the trusted third party. So they will be keeping. So this is CA will be keeping your vendors' public keys. Vendors has to pay. For users, it's free, right? We can use it, right? That's what you don't have to pay for anyone, right? But your bank has to pay to the CA to keep that for every year. You have to make a payment, right? Few $1,000s, right? So they will be charging just to keep your public key, because then only it will be working. So that's the same thing. So known as trusted. And then there are so many things like in the digital certificate, right? I think I also have asked in the exam paper, write down 2 things that are there in a digital certificate. One important thing is public key has to be there, and then validity period, to and from, because the certificates are being valid only for certain times. That's why, like, they say sometimes you will get a message saying this is no longer trusted, we can't go, because browser just start pushing you saying that this is not a trusted place to go in, because the public key was not available, right? Because you have to pay for the CAs, and then if your deadline is today, like tomorrow, if your bank is trying to, customers are trying to reach the bank, they won't be able to unless you have extended your this certificate. Now, so many things are coming. So this is your message. In the previous case, double signatures or double encryption, I said we add the digital signature as well. Then we can authenticate and get the non-repudiation or confidentiality of your data, right? Or and who the sender. But this whole thing has to be encrypted by the public key of the B, right, receiver, right, or the bank. So then it gets through the digital signature. So like this picture shows, right? So that everything comes here. So digital signature is doing something. Digital certificate is just giving you the receiver's public key. That's all, right? It does not provide anything else. And it seamlessly gives to you because that's where like it's transparent to the end user, what we call, right? Just end user doesn't know anything about this encryption or whatever. That's the beauty of that, right? But we can't do that with digitally signing thing because end user also has to get involved. That's where like within the organization, we can do this securely and very well. But with different levels of end users, it's not easy to do that, right? That's why like because of the digital signature only, that other thing also very popular because then we can do that. If not, we have to ask each and every customer of your bank, come to the bank and take your the public key of our bank and install in your browser. So if people do not know how to do that, that's going to be a bit of a problem to do, or as bank has to send the IT staff to each customer's home computers. And you know that itself is going to be another troublesome activity for the banks to do. But luckily, we have these digital certificates, right? So this is where like, I'm not saying digital signatures and digital certificates are combined, like just the whole picture I have tried to give in this slide, everything, right? So don't get confused now, right? Most of the banks are now no longer using this, right? They are using plain text with digital certificate, right? In your companies, probably you don't need that because you can put a public key by yourself because because head office, branch office, right? About like 200 whatever known parties are doing, so that you can do. So in that case, you are using digital signature, but the public key you don't need to get us through a certificate. But there are some companies, they use a certificate as well, and they do run like that, and then you need all. So these are certain certification authorities. DigiCert, GoDaddy, VeriSign. So these are very popular ones, right? So there are other ones as well. So you have to pay for them. So you can see like how much you have to pay. Your company might be paying unless like they're using this method. And this is like how you can go and have a check on your web browser, what certificates are already been installed, right? You can go there. Just I will not, it's a practical side. Just whenever you have a certificate, this is an example. This is a Colombian UCSC certificate I'm just talking about. We took it from DigiCert. This is a time period, and this is what like our fingerprint of that hash of that. What do you call the digital? The public key. So whenever you have this, I think some of you all might have seen this message, and then probably you can go with I understand the risk, or like these days. There are other things like if you are using Chrome, you can use different versions of Chrome as well, Firefox, like different ways behaving. These are we call self-signed certificates. You are not going to the CEA to pay and use it. You will be using your certificate by yourself, right? But then you get this message because browsers want you to go and pay it to the CEA. That's another business I said, right? So browsers and the certificate authorization and certificates, things like organizations have a nice deal, right? So the browser is the one who blocks that. So then it allows us to go there. But even with that, if your company says that, go ahead and you can say, I understand the risk, and you can do the certificate, or your IT department comes and install the certificate into a computer, that will be all right. Yeah, one final thing that again, this whole transaction, I want to teach you like what we were talking about throughout. Now, this is what we were. Let's say you are a customer from a bank, you have a credit card, right? This first of all, like this assume 1 and 2 is just everyone has, as of the MBA students. Now, what you do is you want to get from something, buy something from a merchant, then you have to send your credit card details. What you do is you send your credit card details through a channel. This is we call SSL, right? Or we call HTTPS, right? Similarly, if two companies, your organizations, or the private cloud and the public cloud communicates, that's we call a VPN. right? Then technology is same, like the same way of implementation, but different technology. SSL, secure socket layer, which is for the mostly the HTTP, right? But then VPN will have similar technique, but this is same thing, public key, private key encryption. So you send through that way, you use merchant's public key here. So K pub, I put here M merchant, right? And that's what you send. And then merchant will be, once merchant get your credit card details, it checks with its bank, that system, whether it's okay. Then this is a banking network. Either this is where like you have Visa or MasterCard or some other network, right? And that's the way you have to pay for this as well. And then it checks with the Visa, MasterCard through that network with our bank. They check the request authorization. The bank says, okay, you can go ahead. We have given him enough credit, right? This bank says to the merchant, yes, no problem. I got the certification that we can go ahead. Now the merchant is happy. The merchant will be sending the confirmation, yes, we can send you the data. And then, of course, if you buy something like this, you can't send it through the internet. It will be shipped, right? But then the whole transaction is over. But after that, once you get the goods, what will happen is this money will be transferred. And of course, you need the bank that needs the money. So the bank will send you a bill. And of course, you have to settle that, right? That's what it basically does, the whole process. But I was talking to you all only this part, the green color tunnel, that is how to send securely, right? So how to send securely your data, that is your credit card number, CVN number, CVS number or CVN number, right? And then expiry date, whatever, to the merchant. So that is very safe, right? No one here in the middle, bad guys, can take your data. But the merchant might be able to put your data in a database. Later on, a bad guy comes and hack this system and get your credit card number. That is a different story, right? That is about merchant is providing that data, or like merchants has leaked that data. It's not the HTTPS or secure communication, right? So these are, okay, now that's what, like, people, please, if you have any more questions, you can ask, right? We have time, so I'm not, yeah, we have the 20 minutes more, so don't worry. Right? There are a few more examples to be discussed, right? But this is the whole process, right? So then this public key encryption is just creating how to create this tunnel, because what we did was basically we took the credit card numbers, get the merchant's public key, and then we encrypt and send it the encrypted message, right? And then he was able to decrypt it, right?
So question.
Yes, go ahead.
Even if it's okay, say it's a secured site, would you still recommend saving your credit card details, because they request for that, right? They ask you whether you should save your credit card details.
Yeah, maybe, yeah, because they will be, I don't know, like this banking side, someone can help me on this, who can have expertise on that. But I don't know whether merchant has to keep all the details, right, of our data of the credit card details here in the merchant, because it's the merchant bank and then our bank with the Visa or MasterCard. The transaction is authorized, right? Whether you need to keep, because you want to backtrack certain things, auditing purpose, you need that. But that's why, like, so a lot of examples I will show you in next few slides that are leakages of your credit cards, not on this. This is very, very safe, I would say, right? Can I put here 99.999% safe, like you are sending a credit card detail. But the bad thing happens most of the cases, right? Here, right? They have recorded it, and then somehow people have hacked those machines and got it back, right? So that's what I also don't know, like a merchant has to keep all these records in his database, right? That's in the banking side, or from auditing side, you all have to check from the financial side. But I think if it is not there, I think this is going to be much more safer world for us to be in, right? Because the leakages are happening from there. And since you asked that question, like whenever you all are doing, I recommend, like, now you have something called web cards as well, right? web card or internet card. Different banks have different terminologies, but that's like, because it's kind of like ₹0, but you can top up whenever you do a transaction. So then at least your card will be there. Someone takes over like hacking, right? But then whenever you want only, you upload that, that will be good, rather than having right, 1 million credit limit, right? And then sometimes you have not checked, like small amounts have been taken, and then you have not checked your credit card statements or whatever, right? So that's another good thing. So that I'm not saying to communicate here, you have to have web cards, because I said whatever card is okay, because we can give a good guarantee the way we are doing. But however, once it's been recorded in certain places, there can be some issues. Okay, so if there are any more questions, we can ask. These are like, this is Edward Snowden has leaked. He says in one of his documents, the Washington Post reports that according to the new documents leaked by Edward Snowden, NSA, National Security Agency of USA, has been securely tapping into the main communication links connection, both Yahoo and Google data servers. So that means what they say is like, this is SSL, secure socket layer, right? Whenever we communicate with the Google front end, right? This Google front end, that is like Google front end, it's secure, right? So this is HTTPS. This is, but then it says whatever inside is plain text, right? So we do all secure thing, but then they say here, where is that? NSA, like, looks like NSA has a backdoor entry, right? So then these are all our mails are here and here, right? These are all in plain text. So then anyone can read. That's what like this is what he has leaked, not me, right? So don't take me to court. But here, these are some cases like the passwords of 32 million Twitter accounts have been leaked when 2016, right? So if your password is from 2016 is same in the Twitter, someone might be using a password for something. And that's why, like I said, don't use the same password for Google and your Office, right, database server as well, because then they can access that as well. 68 million Dropbox accounts have been hacked, right? These are all not HTTPS like secure thing, right? The databases have been hacked. LinkedIn, 6.5 million encrypted passwords have been hacked. Yahoo confirms a major breach. Just Uber concealed huge data breach, right, in 2017. So these are just, you can see stories, just I put few, just make it a slide and try to give you, that is what the reality, right? So especially when you're having your username passwords per username, per application, have a password, right? And when you are doing credit card details, right, try to use that kind of web card or whatever, and then try to make sure that because the transaction can be secure, but after that is the issue. This is another website. You can go to this URL, right? You can see like these are MySpace. Now MySpace is not there, but where was that? Sony PlayStation, right? There are some well-known big ones, Apple, Adobe, right? That's like different circles are there, right? So all, there are some breaches, right? So they all have, so here at the Sony PlayStation, they also have kept a lot of credit card numbers. And that's where like a lot of credit cards have been leaked. They have kept all the data in their database, and that is been leaked. So that's a bad thing when you're doing transactions. And this is, I told you last time as well, you should never check your password, how good it is, right? With other systems, because they will be keeping a copy, right? So never ever do this. Must change often. So this is about your password. Must change them often. Do not share with them. Do not have them lying around, right? So this is like thing some people, I didn't put that one. This is always they are compared to undergarment, right? So same as your passwords, right? You should change it often. Do not share with them, anyone. And then just do not lie, just let them leave just idling everywhere, right? So the same as that you should be using your passwords. Yeah, this is just a tool like just awareness, because one of the MBA students sometime back, about 4 or 5 years back, someone asked, is there a way that we can send securely email on Gmail? At that time, I also didn't know. I said, to my knowledge, is not. But so when you ask a question or when you challenge me as well, I'm so excited, because that's what like we also have to learn, because IT field is changing very fast, right? I can't do the same thing, right, over and over, right? So then, if I do not update myself, so then soon after that question, I also went through and start searching, and then I found a solution. Yeah, there was a solution someone has implemented, something called Mail Be Locked, right? That you can make Gmail and Yahoo Mail send secure. This is an extension. You have to use only Chrome and Firefox only, it is working, right? So it's basically you can implement that security that I was talking about. That it includes both methods. I can send a secure mail using your public key, right? So if one of you all create your key pair and send me the public key, I can encrypt and send it. So you can open. And then I can create my pair, and then I can digitally sign and send it as well. So this is a very nice thing. There's a nice video, right? That's where I go to YouTube and type Mail Be Locked, right? That's what the tool is called, right? This is not being done by Google, by the way, right? They don't want to probably. That's why, like as Edward Snowden said, everything is plain text inside that. If we do this way, it is not, right? Because then everything is encrypted and kept it in their servers. But I'm not asking you to use straight away, but maybe you can watch it, and then if you are interested, you can try it, because there are some how to use them and then how to install that as well. There are some videos, right? So just search for Mail Be Locked. You will be able to find some solutions, right? Maybe you all can try. Okay. By the way, anyone who is using Outlook has this feature, and actually both features are there. One is securely sending, and that is other one is digitally signing and sending, right? Both. But yeah, so now you can talk to IT department, right? And if your company has taken a policy not to enable these two, probably it tells you something, right? But if you are a person, you can make it to enable, so that everyone has their security enabled as well, so that you can send securely mail across anyone, right? No one can in the middle read it, right? Because if you want to prove that as you are the CIO or CEO of the company, you want to give a good impression to your users. No, we are not really, right? So you can say we have enabled secure email as well as digitally signed document emails, right? So you can use both options or either option, right? And make it your communication secure. We don't care about that, right? So that tells like a good relationship with your fellow workers. That's like you tell that, okay, we are not really bothered about what you send across, but as long as you do your duty well, right, we will be happy. So that's why like some people will not be enabling these options, right? Because this is security is good, but sometimes more security is not good for their survival, or they won't have that as well. Again, I'm not going to teach this. This is again another tool. If you all are looking at, if you ask, is there a good tool that I can use to securely save my data, passwords, like important documents? Something called VeraCrypt. Why I'm saying it's good? Because it's an open source software. Now it is an Apache license, you can see. That is like, okay, now this is good. That's what like, I just took this. This Apache license means this is permissive. Can you remember my lecture? Permissive. So then you can take this software and customize, and then you can keep it to yourself, because like GNU GPL license, where you have to give the source code, because security is without source code, don't trust anything, right? So this is a software which comes with source code. This is a free and open source software, but this is also permissive license. Because of that, you can get this code and customize and just even close it and keep it with you, right? That beauty is there, so that your IT department can make it. But as individuals, you can use, again, watch some videos on VeraCrypt, how to use. It's a very nice tool. You can do it. This is another one, CipherThread, right? That is also a secure thing. And again, if I say it's free of charge, free speech. That means like GNU GPL license, right? This is open source, right? It's, I think this is a GPL one, right? Yeah, this Bitcoins, I will not go too much into that. Bitcoins also use security, right? Because I will be giving some topics soon to you all with this as well. That's what I just kept it like after that I will be releasing this, right? You will be getting the topics as well as I promised, right? But some of you all will be getting about this Bitcoin. This is cryptocurrency, right? Just try to find where this person is, which country is from, is it really there, right? That's also another story. But however, this is a kind of currency that we can have, but that is, again, we are using same public key, private key encryption, and no one in the middle come and do anything, right? But only thing is then there's no concept of central banks as well, because just end user. Now, security means end to end. Sender, receiver, no other party, including government, treasury, bank, World Bank, whoever, right? Cannot be inside. That's why like Bitcoins have that. And it is using something called a blockchain. Blockchain is a ledger, a distributed ledger, and it is open, public, and anonymous, right? That's why like it's a very interesting concept that it uses, right? Security embedded, right? Open method. So that is what I was trying to talk to you all within this. I was just trying to do another topic, but due to time restrictions, I could not be able to complete that. So that, but however, which are related to business, I have discussed. Only thing is just I was thinking of like talking about a little bit on AI side as well, but I could not because this is I think this is the 5th lecture. So that with that I will be completing my part, and then Dr. Nuradi will be taking over from here.